me do a couple quick chapter announcements and then turn it over to Christy and she'll introduce you.
Okay, sounds good. Perfect.
All right, ready when you are, Christy.
Ready. I'm ready.
All right, let's do it. All right, good afternoon, everybody. Welcome to our February 16th, 2021 ASSP Cascade chapter meeting. We'll start off with a few chapter business announcements, and then we'll get started into our speaker time, which Christy will introduce for us. So first off, our virtual meetings are going to be continued until further notice. That's our guidance from the ASSP Capital. And just a reminder for everyone, we do still have hardship memberships available. So if someone has experienced a loss in employment or a change in employment during these challenging times, that hardship memberships are available. You can contact the primary ASSP number, or you can email them at customer service at ASSP, and they can send you more information on that. To let everyone know, at our recent executive officer meeting, we decided to continue our donation and support of the OES organization, and that's our youth support for health and safety. Every year they do a video contest, which is really neat, and we voted to continue to support that. And that contest is open, and I can share a link if anyone is interested in sending that information out to their own school community. I'll send that out here in just a little bit into the chat section. Our Hispanic diversity webinar, not ours, but it's Hispanic diversity is a new group that ASSP has created, and Naomi Hernandez, one of our members, is the state representative for that. So really exciting stuff. And they're going to have a webinar Tuesday, February 23rd, and also Friday, February 26th. And I'll put some links in for those registrations in the chat here in just a minute. And then one last one, that we've had a few recent job postings on our webpage. So if anyone's interested, those are on there. And otherwise, I'll turn it over to Christy to introduce our speaker.
Excellent. So those of you who may have joined us late, we're just going to kick off our meeting. Please mute your microphone while we do the presentation. And if you've got questions, raise your hand or use the chat function and we'll monitor that. And today we're really excited to have Matt Harper, who's the director at G2 Consultants, a DKI company, here to talk to us about industrial hygiene. Matt is a certified industrial hygienist and a certified safety professional based out of somewhere in the Portland region. You'll have to clarify that. I know my business has done some work with G2 Consulting and has learned a lot. And so here we are to talk about industrial hygiene. Thank you, Matt.
All right, thanks, Christy. Yeah, I've done a fair amount of work with your organization, and I have a feeling that we've probably done some work with folks that are on this presentation as well. And we might have maybe crossed paths with some of the folks at we typically, back when conferences and conventions were still in person, still a thing. We were typically down at the Eugene, I can't remember the name of it. It's the OSHA conference down in Eugene. I think it was last year, right before everything shut down, I think. So yeah, that being said, we are G2 Consultants. We are we're headquartered actually in Lake Oswego, but we have other branches in Eugene and in Bend. And actually our headquarters, our corporate office is actually in Chicago. So, but we are a kind of a turnkey industrial hygiene and occupational safety and health consulting firm. So we help clients with a variety of different, I guess I'll kind of jump the gun a little bit here. I guess I'll go into kind of the presentation here. So yeah, I'll give you a quick background on who we are and a brief overview of industrial hygiene. And then we'll kind of cover hazard recognition, evaluation, and control. And I felt like I could throw in some information on kind of what industrial hygienists are doing in a pandemic situation. So there's been some unique challenges and unique services that we've been providing for the past 9-10 months or so. So now I'll get into kind of who we are. So yeah, so we provide our clients a wide variety of different services. I'm kind of the technical lead in our office and provide most of the industrial hygiene, kind of the nuts and bolts industrial hygiene monitoring that we perform. So now I'll obviously get into that in a little more detail. But we also help clients with developing safety programs, doing safety audits, OSHA compliance. It's kind of our kind of the way that I tell people what we do is, people ask if I work for OSHA, and I say, no, I don't work for OSHA. My job is to make sure that your employees stay safe, and that if OSHA does come into your facility, that you are well prepared. So, like I said, a lot of safety program audits. We also provide a big core of our business is performing regulated building material surveys. So, if like you were doing a pre-demolition of your facility or a renovation in your facility, we would be the guys who come in to do like asbestos surveys, lead inspections, other regulated waste such as mercury, PCBs, things of that nature. So we work in a wide variety of different industries. It's in the federal government, as Chrissy said, cities, public works. Probably the majority of our work is in the K-12 and higher education. University of Oregon, do a fair amount of work for those folks. We've also a lot of retail work, construction, high tech, pretty much lots of different industries. And I feel like we've worked in pretty much all of them. So, and it's, as Dennis mentioned too, I just before I forget and get to the end of this presentation, I also do want to mention that, yes, at G2, we are also hiring. So I don't think I hadn't got around to getting it posted on your guys' chapter website, but my contact information will be at the end of this. So if anybody's interested, feel free to reach out to me. It is posted on Indeed, but this is a little buzz marketing for us, I guess. So, all right. So this is the background on industrial hygiene, and this is a very, very nuanced topic. I know this. I've got until 1 o'clock to talk. I am not just a disclaimer here that I am no way, shape, or form going to cover absolutely everything. You could spend 4 years going through and learning. I spent 15 years in the industrial hygiene field, and I'm still learning things. So some of the stuff will be fairly basic. Some of the stuff you might already know, but this is meant to be just a quick overview. And again, I have no problem, fielding questions, providing further clarifications on anything industrial hygiene related after the fact. I'm got an open door. So, but this is the depending on where this is pretty much the explanation or the definition of industrial hygiene. When I was putting together this presentation, I found this in numerous locations. I reference in this presentation the American Industrial Hygiene Association, the ABIH, the American Board of Industrial Hygiene, so AHA, ABIHA, or ABIH. So a few different sources. This is actually, and I've seen this in multiple places. Actually, the computer that is, I've got my laptop set up on a couple textbooks. One being the Fundamentals of Industrial Hygiene. I referenced that book a lot in this as well in this presentation. But IH is the science and art devoted to the anticipation, recognition, evaluation, control, and confirmation of protection from these environmental factors or stresses arising from the workplace, which may cause sickness or impaired health and well-being. So industrial hygiene it's a field that I truly love, because it is part science. It really is part science and part art, and it's sometimes it's part armchair therapist too. But it really melds those things together. I have a science background myself, but the technical, to be proficient at this is it does take quite a bit of practice and experience. So industrial hygienists usually are engineers or somebody who's been trained in the physical sciences. Sometimes they come from more of a safety background as well, but I come from a science background, and chemistry is not fantastic. So if I can make it through and you have a chemistry degree, you'll be fine. So we kind of talked briefly about toxicities and hazards. So when we're talking about toxicity when it comes to industrial hygiene, it's basically the ability of the substance to produce injury when it gets into your body. So at a certain concentration. So, and the hazard, and is that most people that have a safety background, you'll kind of recognize this as, if you're doing risk assessments as far as, hazard severity, what's the likelihood? So the hazard is what's the probability or likelihood the substance will be in your body at that toxic concentration. So let's see. All right. So this is probably something some people have also maybe had some familiarity with this. It's the dose response curve. So when we're talking about like toxic substances, well, first off, any substance can be poisonous, just depends on the dose. And I always think of the example, maybe people will remember, this was probably 10 years ago. If people remember, there was a FM radio station promotion. I can't remember where it was out of, but it was the promotion at the time was to win a Nintendo Wii. And it was the contestants. It was called "Wii for a Wii," I think, which was they had to go. Whoever could go along without peeing would win a Wii, and they had to drink a bunch of water. Well, one of the contestants actually died, and it was basically she overdosed on water, and she couldn't flush her system out. So even water, depending on the dose, can be lethal. So, but every concentrate or every compound has got some type of curve to it or some dose response line. It may be a linear line, maybe an exponential line, but you can kind of see here is that, as the dose goes up in this example, you will see the response ramp up and then finally sort of plateau. So we kind of get this information based on a lot of like animal studies that we use, and people may be familiar with the term LD50 or lethal dose. And LD50 is the dose that kills 50% of the test population. So, and that type of animal studies, usually you'll use mice or rats or sometimes smaller invertebrates or fish, but that type of laboratory data, which really drives what our understanding is or our understanding of the toxicity of these compounds. And that information in turn is subsequently used to help develop the exposure limits, OSHA exposure limits. And we'll kind of talk a little bit about exposure. Well, we'll talk about exposure limits, but not maybe in specifics, but there's OSHA exposure limits, which probably most people are familiar with, but there are some recommended exposure limits that are established by like the American Conference of Governmental Industrial Hygienists, which we reference a lot too, because those these recommended bodies or these entities that put out these recommended exposure limits are usually err a little bit more on the side of, or a little bit more conservative than the exposure limits that OSHA has established. So the routes of entry, so inhalation, absorption, and ingestion. So when we're talking about workplace exposures, the primary exposure is going to be inhalation. The absorption is probably, I'd say it's probably in the order. I guess it's probably in the right order of risk, I guess. So inhalation, basically breathing in airborne contaminants, whether it be, I should put fumes, dust, mists. That could be a road crew, a public works department, or a construction company, that's working with jackhammering concrete. So, the concern is breathing in silica dust, breathing in just or just dust in general. It could be a plating operation or with a dip tank that we have chemicals, organic vapors, and solvents off gassing. So that's the primary one. We put ingestion well as probably the third most likely. It's good to understand that it's good to have employees that recognize, or I should say, employees should have an understanding that if they're working with things such as working with lead solder, and that there has to be some hygiene practices put in place that they're not transferring the potential lead that's on their hands to their mouths if they don't wash their hands prior to eating or smoking, etc. So here are a few different types of chemical exposure limits. And the primary one, this is the one that OSHA, Oregon OSHA, federal OSHA, if you go up to Washington, labor and industries, these are the ones that you see the most. And so is the top one, the 8-hour time-weighted average. So what is that person's exposure averaged over a standard work shift? And if you're looking at OSHA exposure limits, for the most part, that's what they use. And even if you have employees that are working 10 hours or 12-hour extended shifts, you'll typically see, it's basically what is that 8-hour average? That's what everything is based on. So permissible exposure limits, or PELs. Again, if you go to ACGIH, they have their versions, which are TLVs, or threshold limit values. And a lot of chemicals, or some chemicals that are more nasty in nature, may have short-term exposure limits, or I should say, when I say nasty, it may have more, the health effects associated with those are more acute in nature versus chronic in nature. If it's got an acute hazard, you may see a short-term exposure limit. But basically, that is also based on a 15-minute, or it's based on a 15-minute average versus an 8-hour average. And ceiling concentrations or ceiling levels, it's basically thou shalt not cross this level. You cannot. There's a max that you can't exceed. So, and then there's some chemical specifics, such as some chemicals have standalone specific standards, such as formaldehyde, hexavalent chromium, lead, where they have an action level as well. So that's where basically a trigger point. It's below the time-weighted average, or a PEL. It's usually typically it's about half of the exposure limit. But if you cross the action level, there's usually some things that as an employer you have to do. You have to have usually it's medical evaluations, periodic personal exposure monitoring, assessments, training, and program requirements. So let's see. All right, so I think this one kind of gives you an idea of the chemical exposure limits. So for this particular compound, the PEL as a time-weighted average is 10. This also has a ceiling level. and you kind of see that we're hovering somewhere around, and it probably averages out, even with that big peak, it probably averages out to about a little more than 10 parts per million. So, and that's typically when we're, well, I'll get here. I think it's probably the next slide. So jump ahead of myself here. So I vacillated. I kind of went back and forth whether or not to include these next couple of slides, but I said I ended up just kind of keeping them in there. But it's kind of important to have an understanding of, you know, what the airborne hazards, and this is from pretty much here on out in the last couple slides, we're focusing on inhalation hazards. Now you will see some. Well, yeah, like I say, we're just going to focus on inhalation hazards since that's the main route of exposure. So I think most people, this is why I kind of vacillated whether or not most people understand what a solid is, what a dust is, but there are some slight differences when you get into difference between dusts and fumes. You know, they're all, you know, a dust, fumes and smokes. I mean, those are all at some point are solids, but you know, they have slight chemical or physical variations from, you know, just your typical solid material. But again, it's important to think about, or it's important to recognize, you know, what types of hazards, and this is sort of the takeaway of this whole presentation, is what type of hazards do you have at your site? And it's being able to recognize, you know, and evaluate certain processes and have a critical point of view during your analysis and say, okay, this person is doing XYZ tasks. You know, what are the byproducts or what are the hazards? And most people, I would assume, that are on this call are used to doing, you know, safety hazard recognition work, you know, evaluating a task and saying, you know, this is the ergonomic, this is the ergonomic risk, or this is the ergonomic hazard. This is, you know, they're dealing with XYZ tools. You know, these are the safety hazards. This is no different than that. It's okay, what chemicals, what processes are doing, and what could be the byproducts of that. So, and, you know, it's important to know that maybe smoke's coming off of maybe fumes. It's maybe just dusts. So here's kind of another one with the kind of liquids and mists. You know, these are, you know, certain. Yeah, I think I'm just going to kind of cruise through this one because I think, you know, there's like kind of with the solid states. These are just different states of liquids, and then you have gases as well. So. Okay. All right. Hazards arise from excessive airborne concentrations of vapors, mist, gas, dusts, and fumes. So as I kind of previously mentioned, the exposures can result in acute or chronic health effects. And I mean, and it's also important to know what chemicals or what parts of the body, what parts of the systems that certain compounds target. So it's good to know that, you know, this is sort of important. And I have not covered safety data sheets, and that's not included in this presentation. But it is probably worth noting that, you know, having a strong hazard communication process at your work site is vital. So, I mean, this is no different than your standard HAZCOM, where, you know, knowing what chemicals that your employees are using and what those risks are and what parts of the body that, you know, there's some things that may affect your liver, some might just create eye irritation. I mean, some things are obviously carcinogens. So I kind of threw in some of the nastier ones. I kind of picked the ones that give you cancer. So, but yeah. So I mean, again, this is a list too of, you know, different compounds. You know, benzene you may see in, you know, certain, you know, pesticides or cleaning products or industrial solvents. Kind of same thing with MEK. And asbestos is something that is pretty ubiquitous to a lot of built environments, especially older buildings. And I always throw hexavalent chromium in there because that's a very nasty one that has very low exposure limits, and it is extremely easy to, as a carcinogen, but also is extremely easy to exceed that exposure limit, especially in like hot work situations. So welding, cutting, torch cutting, grinding, etc. So, but industrial hygiene, while I would say that the majority of when as an industrial hygienist, when I am asked to, conduct an exposure assessment, I would say majority of our work has to do with what I previously mentioned with like airborne contaminants, but there are physical hazards too, and probably the most one that we get requests for a lot is noise surveys and noise assessments, personal noise exposure assessments. So noise, Oregon OSHA has got a very robust hearing conservation standard for hearing conservation. So, and noise is one of those that has a permissible exposure limit and also has more or less an action level too. So, but noise is one that this is something that we do a lot of, and I could probably do at least 2 to 4 hours on noise easily, probably a day's worth on noise. So it is simple on its face, but it is actually a very complex it's a very complex topic once you kind of get into the weeds. So, but it is important. That's a very easy. If you're looking to start your hazard assessment of your facility when you're looking at through like an industrial hygiene lens, noise is one that I would definitely, you should keep that at the forefront of your mind. And it doesn't need to be constant noise. It can be intermittent noise, but it is, even with like intermittent noise, it is not, it's not out on the possibility that you could have people, even with 4 hours of exposure or even 2 hours of exposure, to have a time-weighted average, an 8-hour time-weighted average that exceeds the OSHA exposure limits. So, and I do always like to kind of remind people too that as I previously mentioned about the 8 hours, OSHA sticking with those 8-hour exposure limits, OSHA, especially in Oregon, does have, and I think it might be a federal thing, if I'm not mistaken, but pretty sure it is. They actually have they have action levels for noise that vary depending on shift length. So they actually do take into account an 8-hour, a 10-hour, and a 12-hour, and they probably go out further than that. So now their permissible exposure limit doesn't change, but that lower action level will shift. So just keep that in the back of your mind if you got folks that work extended shifts. And by the way, the exposure limits, the action level is 85 and the PEL is 90 for decibels for noise. So that 85 will shift down for the longer people are working. So again, just know that even if you got people that work 12 hours and they're below, they have an exposure that's, say it's at 84, that doesn't necessarily mean you're in the clear. And again, but if you're above the action level, there are things such as, you have to have a written hearing conservation plan. There's some training requirements, audiometric testing, and some hearing protection need to be made available to your clients. But again, it's sort of digressed into noise. We do, other physical hazards. There are, extreme temperatures, hot, cold. That's ionizing radiation. I am probably not the best person to speak in any sort of detail on kind of the radiation. I haven't done much, and I know, I feel like I know just enough to be dangerous on those topics. So when I took my CIH exam, I had quite a few radiation questions. I felt like I was white knuckling it for 2 hours. So, okay. So yeah, hazards. Yeah, probably the second biggest physical hazard, though, at least in my experience, is ergonomics. So, the hazards that arise from poorly designed work processes or procedures can cause injury. So, this is when designing the tool and the job to fit the worker is of utmost importance. So, usually engineering and biomechanical principles need to be applied to eliminate these hazards. So, just remember that, or just keep in mind that not everybody is shaped the same or made up in the same fashion. So a job that has been designed for somebody that is my height, who's 5'10", may not be a process that will work well for somebody who's 5'2" or 6'5". So we'll get into sort of the evaluation process, but this is where it really takes boots on the ground to develop, to do physical assessments, do observational work of the people, and figure out where those ergonomic hazards may be present. So, and again, ergonomics is another one you could do. I mean, people make their own whole career on ergonomics. So, yeah, we're not going to touch much on that. But also, we want to talk about like the biological hazards. We'll kind of talk. You see the word viruses in there, so that's kind of talk about the COVID stuff at the end. But we also, it's very common that we'll do, as an industrial hygienist, and especially as a consultant, we do a lot of sick building syndrome type of things, indoor air quality assessments. So lots of times we'll do microbial sampling, fungal sampling, air sampling, bulk sampling, those types of things. Bacteria is something that is a little less common than the kind of the mold world, but and I would actually like to talk more about kind of the mold work, but it's a unique kind of corner of industrial hygiene, I would say, because as I've sort of mentioned prior about OSHA exposure limits and recommended exposure limits. Now, for mold, there are no exposure limits, and there will be no exposure limits. I can't see how there could be exposure limits for mold. So, I mean, the issues are, we look at, it's unlike, we can't, they could maybe do animal studies, back to kind of the dose response slide, but it's too individualized. Our reactions are how our body responds to these types of environmental factors, specifically mold. Christy may respond to a certain type of mold that I have no response to, and vice versa, or may have different health effects to it. But and since it's pretty much everywhere, first off, you probably will be no standardized thresholds, because if you're comparing results to or outdoor concentrations of mold in Eugene, Oregon, well, those are going to be different than you might see in Phoenix, Arizona, or in Jacksonville, Florida, or Buffalo, New York. They're all going to see different concentrations and different speciations. So the best we can do is more or less just compare what we see outdoors versus what we see indoors. So indoor and or outdoor sampling. So I think to kind of cover this as far as, this is the hazard evaluation. This is where you really need to make those on-site observations, talk to employees, do measurements, and kind of talk about the measurements. So this is sort of as an industrial hygienist, this is our air monitoring is our biggest, our main tool in our tool belt, so to speak. So what do we want to accomplish with air monitoring? So we obviously want to identify what the concentrations are, the atmospheric or airborne concentrations. That's how we evaluate workers' exposures. And there's some other times that helps us set internal protection levels, helps set our PPE requirements. And I highlighted that one to verify the conditions have not changed. And you'll see if you read through enough, chemical standards and OSHAs, they basically say that you have to evaluate exposure levels anytime processes or productions change or vary that may lead to new or additional exposures. So that's why I say verify conditions have not changed. Just because you did some monitoring, I'll use the dip tank again example. So you did some monitoring on an employee that's running, operating a dip line, but then you reconfigured that dip line a year later, or you substituted chemicals out. So it probably would warrant a reevaluation. So yes, persons should be competent. Persons providing the air monitoring should be competent. So they should be trained on how to use it. They should be tested on how to use it. And they should also, probably the biggest takeaway is they should also know the limitations of that equipment. So just a quick example, I have a client who I met with just last week, and for the last 5-10 years, they've been doing their own personal noise exposure monitoring in-house. And they called me in and they said, Matt, we don't want to do this anymore. We feel like we know enough to be dangerous, and we do it so infrequently, the monitoring, that we have to kind of relearn it every single time we do it. And then we don't want to, we want to hand this over to you because we don't want to keep up with the calibration stuff, which we didn't know about. We don't even know if we think we got an idea of how to interpret the data, but we're not quite sure. So, in this case, this client had the self-recognition that there's some liability with them taking that work on themselves. So they'd rather just have me and my liability to handle that. So things to keep in mind. So air monitoring equipment should be portable, should provide useful and reliable data, should be sensitive. I always recommend intrinsically safe. There's lots of air monitoring equipment. I own some air monitoring equipment that is not, and I'm not sure why I own it, because you just don't know what type of environment you're going to be. At least as a consultant, I have to be prepared for just about any type of environment. But again, all these folks kind of know what you guys know your workplaces, so you make the right decision. If you guys decide to do your own air monitoring, just make sure that you are getting the equipment that is the most appropriate for your operations. So, all right. So there's more or less two types of air monitoring methods. There's sort of a third type too that I use quite a bit as well. I'll kind of briefly talk about, but these are kind of the two main types. So integrated sampling. So we're using air sampling pumps. These are small portable pumps. I think I've got a picture of one on the follow-up slide, but they're usually hooked with a Tygon tube, rubber tube that runs up to some type of media. Usually it's like a filter cassette. I'm pretty sure I've got a picture of that. But the cassette hangs in the person's breathing zone, and it monitors personal exposures. And there's also direct read measurements or instrumentation. And I bet most people, especially most people in the safety field, are probably more familiar with the direct read instruments than they are with the integrated methods. But the integrated methods, in my opinion, and in most cases, are the most appropriate for evaluating occupational exposures. They are the ones that are chemical specific, typically very reliable. They almost always, well, I would say always require a laboratory analysis of some type. And if you are wanting to get into taking your own samples, just make sure to make sure that the laboratory, you are using an accredited industrial hygiene laboratory. Usually if you pop on the lab's website, they'll have that information, their accreditations, but yeah, just make sure, again, it's a CYA sort of thing, that if you get into some legality or some legal issues and you have to defend your sampling and your lab's work, that they have the appropriate accreditation. I know, just doing litigation work myself, that's one of the first questions I ask when I'm on the other side. What lab did they use, and was that lab accredited? So there are a lot of QA, QC processes that those laboratories have to adhere to maintain that accreditation. So hey, there's a picture of it. The guy, it's like the picture's probably from the late 80s maybe, but that pump is probably also from the late 80s. There are newer, faster, cooler personal sampling pumps out on the market right now. But you can kind of see here that it's a personal sampling pump. These pumps can be calibrated to a certain flow rate, and it depends on what you're sampling for. Every analyte compound will have a analytical method associated with that, and per those methods will have instructions on the amount of flow rate, how much air you're sucking through this filter cassette, and what your total sample volumes are going to be. So there's usually minimum and maximums, and typically that'd be the same thing with the flow rates as well. You can run it between, lots of them are like, you can run between 1 liter to 4 liters, do not exceed 4 liters, or it could be less, 0.5 liters to 1 liter. So just make sure that you understand the methodology. So I'll just kind of briefly talk. I think I got a few minutes here. Yeah, the pumps, I'll just say, quick story. I just bought 5 new pumps for myself, and I kind of went with the pumps that have quite a bit of bells and whistles. You'll see and there's actually pretty common, or starting to become more common, but the pumps I purchased actually have Bluetooth capabilities. So I am able to monitor flow rates, sample volumes, and other conditions of each pump on whoever's wearing them with an app on my phone. And that's a lot of, you're starting to see that more and more. And you're seeing that more and more with these direct read types of instruments as well. So you're seeing Bluetooth capabilities, but yeah, lots of different types. I'm not going to get into a whole bunch of them, but you guys are probably familiar with like oxygen meters or multi-gas meters, FIDs. So yeah, there's a lot of different meters and monitors that are on the market, but they do have their limitations. I'd say the biggest one is the interferences. And again, this goes back to really understanding what your meter can do and what the information in your meter is providing. So it's also important to know that almost all of these meters have interference issues or can experience interferences with other compounds. So you may have a meter that runs carbon monoxide. So if you introduce that meter, like if you were to calibrate that meter, which you should be bumping and calibrating that meter prior to every use, if you expose that meter, that sensor, to 100 parts per million of carbon monoxide, it should read 100 parts per million. But if you expose it to 100 parts per million of hydrogen sulfide, H2S, it will probably read 5 parts per million carbon monoxide. So just know that these meters, you need to adjust for these things and not just take these, the data that you're seeing on the screen as exactly what it is. So there's some data interpretation that's required. So it may not be always used for 8-hour timer averages. However, there are a lot of single gas meters that can data log and can be used. I've used a few for like carbon monoxide. Again, I use that as an example. So, all right. So briefly talk, I kind of want to get through, I want to kind of get through the COVID stuff. So I think a lot of people are probably understanding kind of the hierarchy of controls, which we want to eliminate, substitute. DPA is sort of our last line of defense. So I'm going to kind of skip ahead here. Kind of talk, the engineering controls, if we're seeing like in a safety setting, we're talking about, I guess you could even say like, if we're talking about noise, we find dampening ways, methods to dampen sound, we provide, isolation, separate people from the hazard. We see that with equipment and machinery and typical engineering controls. So when we're thinking IH, we're thinking inhalation exposures, we're talking usually ventilation is the method that we use. So there's a general dilution ventilation, basically using your building's HVAC system to dilute air by bringing fresh air in and sucking dirty air out. But it's the better way, especially if you are if you're dealing with more toxic chemicals or higher concentrations, you're going to probably want to look at local exhaust ventilation. So you see like smoke eaters or retractable arms or fume hoods and things like that, where it'll actually draw chemicals away from the people's breathing zones. Yeah, there you go. Usually requires a little bit more moolah than just using general ventilation. So, all right, I think okay.
Hey, Matt, I'm just going to give you a time check. We've got about 13 minutes till we're done.
Okay, perfect. I think, I think we're good. I want to make sure I spend a couple minutes on this. So I think we're in good shape, Christy. So, all right. So the new, quote unquote, the new normal for IH stuff. Yes, my job completely changed back in. I'm not saying that like I think that my situation is unique to anybody, but yes, we actually, we started getting calls probably back in April. Started probably back in April, maybe as early as March, as far as COVID specific requests for COVID specific services. So I remember talking with just internally talking with other staff members here at G2. I remember making a proclamation or a statement. I said, I think that we're going to have a vaccine before we have any sort of sampling methods for environmental surfaces. And it's like, I couldn't believe that we had a situation where, at that point, testing was so hard to come by that anybody in the right mind would allocate the resources or time to develop sampling strategies for environmental surfaces. So I ate crow about a week after that when I started getting contacted by my laboratories and saying, yes, we do have methods for sampling. And I will go into the nuances. There are some laboratories have better processes or better methodologies than others. The best ones that I have seen, you can actually age and date sort of your virus, and I think you can probably tell you some other information. How what it's looking like from a structural standpoint. Basically the viability. How long has it been alive on a surface? It's if we want to say, and I honestly I don't remember what the general consensus is right now of how long the SARS-CoV-2 virus can live on a surface. Let's just say it can live for a week. Well, some methodologies you can say, I don't want to look for anything that's 8 days or older. I just want to look for 7 days or less. That'll give me an indication that it's still potentially active and has an opportunity to present or cause infections. Now, I'm not going to get into the whole environmental, can you get it from surfaces or not? I haven't seen the definitive data on that yet either, or currently. So, so we've helped out with quite a few, doing exposure assessments. I've got return to work program development. That's a lot of things that IHs have been doing. Obviously, there's been an uptick in N95 test or fit testing and just kind of overall training. I would say I would have been surprised if a year ago or so, if you said, so I would have been asked if I've been asked to poll 100 people off the street if they knew what the acronym PPE stood for, I would say it'd probably be somewhere in the teens, maybe. And I feel like you probably can't go anywhere and not run into somebody who doesn't know what PPE stands for. So, but there is all these efforts that we're doing to protect ourselves from COVID. There are sort of ripple effects and secondary hazards that people kind of need to consider. And this is sort of the programmatic one is, okay, if I am an employer and I'm allowing people to wear respirators and maybe just N95s if you can get them, or maybe be, higher level protection respirators on a voluntary basis. Are we following all the requirements, all the voluntary protection requirements that Oregon OSHA has put in place? So, I mean, dust masks are obviously, you see that thing there. There's no requirements. We don't need a program, or we don't need a medical eval or fit test. We don't have to do training, but we still have to make sure that we are providing this scenario, that we're providing the Appendix D of the respiratory protection standard. So, but again, these are like things that you might not think about. You're like, oh crap, I just got to get my employees as many N95s as I can. But there's still things we need to do. So another secondary hazards is sort of like, this is kind of one of those things that we at G2, we sort of marketed as things to consider. If you pop on our website, you'll see basically this exact language. But understand what are the building issues. If everyone's been working from home for a year and not been in your facility, what are we checking up on it? Do we have mold issues? Do we have condensation issues? Has there been any broken pipes? And we're obviously seeing that here with the weather over the past few days. But I always like to kind of throw in Legionella. So I mean, if we have a water treatment in our facility, a standalone, and we've had stagnant water in our pipes for 6 to 8 months, might be worth doing some water testing to see if we've got a Legionella issue. So also to kind of disinfecting products. This is the thing that I have actually seen. I found it to be pretty interesting. Is that I've been getting quite a few calls from employers that may or may not have, are looking at may or may not have an OSHA complaint, but I've definitely seen that, or employees who are either administering disinfecting products or are in areas where these disinfecting products are being used, and they're having adverse health effects associated with whatever products. Hydrogen peroxide is one that I have seen a lot of. I have actually a friend of mine he manages quite a few dental practices across the state, and he had a claim where he had some dentists and hygienists, dental hygienists in this case, were complaining and went home because they had fogged this practice with hydrogen peroxide, and he went there to check it out. And he's like, "Whoa, yeah, this is a big time irritant." So it's like, yeah, you should not be fogging. I mean, you have to understand that a lot of these products that are on the EPA list, these are pesticides. I mean, you have to understand that you can run into some health issues if you are applying those in human occupied areas. So I mean, some of the stuff's pretty nasty. So and there's also issues of being misused, and not. I mean, first off, just maybe not following the directions, but also, like I said, using way too much of this and causing exposure issues. So, and it's also good to also know that there's a lot of products out there that say or make claims that they are the end all to be all. They don't, they kill everything, but or we see a lot of the claims. A lot of systems you'll see that they'll say ozone free, does not create ozone. I have been researching this stuff for the last 8 to 9 months, very in depth, and a lot of these I've been able to debunk a lot of these systems, especially when they say the ozone factor. A, you don't want to be breathing ozone, and B, ozone wreaks havoc on equipment. So it's Yeah. So a lot of these devices, especially like the ionization and UV systems, they may claim they don't, but over time they break down, they degrade, and they will eventually create ozone. So if you guys want more information on kind of my research and my recommendations, again, there's my contact information. I can kind of give you ideas on systems that I work, systems that I have done testing on myself that I've seen the results. So I can provide mountains of kind of information. But if you want to reach out to me, but that, like I said, there's my contact information. It sounds like this presentation will be made available to everyone, so you will have it because I'm going to keep scrolling. There's some resources that I like. Those are kind of the big daddies of the IH world as far as the AIHA, ABIH, ACGIH is also another great one. I would say, you guys, I would recommend, to supplement your HAZCOM program. I would really recommend picking up the ACGIHs. They have a TLV and BEI book. I can't remember what the BEI stands for, but TLV's threshold limits values. They put out a little booklet. I have it in my hand here. It's pretty small. They put one out annually. They've got it's a great resource. They've got all their exposure limits, but they go into so much detail on basically every sort of IH type of hazard. I highly recommend it. It is my go-to. I reference it pretty much almost daily. So I think we're done.
Oh, you're not done just yet. We may have burning questions for you, Mr. Harper.
Okay.
All right. So now's a great time. If any of you have any questions about anything Matt presented or a workplace challenge that you're working through or an experience you'd like to share related to industrial hygiene, would be totally welcome now. This is that awkward silence, and I will wait patiently.
I love awkward silences. Yeah, that was a lot to cover. Like I said, I kind of went back and forth what to include, what to exclude. It's tough to cover 10% of it in an hour. So, like I said, if you don't have questions, you got my contact information. I'm more than happy to field calls, field questions after the fact.
And I cut and pasted your contact information as well as the links and put it in the meeting chat. So those looking for that information. I also wanted to reflect on one thing you said, which was around knowing enough to be dangerous. And that's always where I feel like I am, where I know a little bit, but I don't know the totality. And when I'm thinking about the health and safety of the employees and the best management practice of really having a neutral third party who's not concerned about necessarily my budget or the politics of my organization, who can make sort of an unbiased assessment about the hazards in my workplace, that feels like a good place for me to be by hiring somebody who this is their area of expertise. So I just wanted to reflect on that. We talk sometimes about what should we be doing versus hiring somebody else to do, and I think that standard always sort of comes back to me about how you hire the expert for those things. So I appreciate you being our expert sometimes, Matt.
Yep. Well, I appreciate being here. So.
All right. Any questions from anybody before we say thank you to Matt? All right. Well, thank you for taking time out of your day and in the busy Portland area while people are undergoing some weather challenges and spending time with us. I'm glad you didn't have to travel today.
Yeah. I look forward to the time when I might be able to do this in person for you guys. So I think I prefer that. So, but thank you again, Chrissy. I really appreciate it. Thank you for the invite, and thanks for everyone for attending, and I'll sign off.
All right. Thank you, everybody.
Take care. All right. Bye.